Hello guys, this is Imanshu from Code Campaign and we are continuing with our binary tree module. So today we are going to discuss about how to write post-order traversal iteratively. So in the previous lecture we discussed the pre-order traversal iterative manner, and a lecture before that we discussed how to write in-order traversal in iterative manner. So today we are going to discuss about how to write post-order traversal in a iterative manner. And this question is being asked a lot in the interviews of Microsoft and Amazon because it's kind of difficult to write the post-order traversal in an iterative manner. The in-order and the pre-order traversal is easier than this. So it's quite a bit confusing when you proceed this problem, and that's why it's being asked a lot in the interviews of Microsoft and Amazon. Okay, so let's go ahead and see how to write the post-order traversal iteratively. Okay, so first let's go ahead and write the post order traversal for this tree. I have already explained it in my previous video where I explained about the binary tree traversal. Let's go ahead and revisit what we had learned in that video. Okay, so what does the post order traversal say? It says first we have to explore the left part or the left node of the particular node or the left side of the particular node. Then we have to explore the right side of the particular node, and then we explore that particular node. Okay, so let me just change the pointer. Okay. Okay, so let's start with writing the post order traversal for this tree. Okay, so first we'll start from the root. So what does it say? It says first we have to explore the left node. So we'll come to the left node, which is 2. Then for 2 also we have to explore the left node. So we'll come at 3. For 3 there is no left node, it's null, so we cannot proceed further. Then we'll move to the right node. Again, right node is also null, so we cannot proceed on in the right direction also. So now we'll explore the value of the node, which is the root, right? So the value of the node is 3, so we'll print it. Now after this we'll go back here because we came from here, so we'll go back here. uh, Now we have explored the left side of this node, so we'll explore the right side of this node, so we'll come here. For this node, there is one node on the left side, so we'll come here, right? After coming here, there is no node on the left side of this node, so we'll explore the right side. There is nothing on the right side also, like it's null, so we'll go ahead and print the value of this node. Okay, then we'll go back here. For this node, we already explored the left side, so we'll look into the right side, which is null, so we'll then print the value of this node. Then we will go back to 2 again. Now for 2 we have explored the left side, we have also explored the right side of 2, so we will print the value of the 2. Now we'll go back at 1. So for 1 we have explored the left side, now we'll explore the right side, so we'll come at 5. For 5 there is nothing on the left side, so we'll explore the right side, we'll come on the right side, so we'll come on 6. For 6 there is nothing on the left side, and then there is nothing on the right side as well, so we'll print the value of the node, which is 6. Then we'll come back at 5. For 5 we have explored the left and the right side both, so we'll print the value of this node. Then we'll go back at 1, and for 1 also, now we have explored the left side and the right side of the node, so we'll print the value of this node. So this is the post order traversal of this particular tree. Okay, so now let's proceed and see how we can write this post order traversal iteratively. I've already discussed how to write the post order traversal recursively in one of my lecture where I explained the different binary traversal. So if you have not watched that video, please go into the binary tree module, and you can see the first video there. So you will be able to know how to write recursively the post-order traversal. Now in this video we are going to discuss about how to write the post-order traversal iteratively. Okay. So again, what was the post-order traversal in the previous 3742651. So let's write here 3742651. Okay. Now there is something very interesting into this sequence if you look closely. So let me write something here. Okay. So let's use this and if you see it closely, this is similar to pre-order traversal, but what we had done in pre-order traversal, we used to travel left node first and then right. We just exchanged this. So right now we are traversing right node first and then left node. So let's go ahead and apply this traversal here and see what the outcome will get. So we'll start from here, right? So we'll first print the value of this node, right? Then we have to explore the right. So we'll go into the right portion. We'll come here, we'll print the value of this node. Then again we have to explore the right, so we'll come here, we'll print the value of the node. Now the right part is null, that's okay. So we'll go on the left side is also null, so we'll go back here, right? Now we have explored the value of the node and the right part, so we'll explore the left part which is null, so we'll go back here. Now here we have explored the value of the node and the right side, so we'll go on the left side. For this node, again we'll print the value of the node. Then we'll go on the right side of this node, so we'll come here. For this node, we'll print the value of the node, and then we'll go on the right side, which is null. That's okay. So we'll explore the left side, which is also null. So we'll go back here. For this node, we have explored the value and the right side, so we'll go on the left side. So we'll come here. We'll print the value of this node. Then we'll explore the right side, which is null. So we will explore the left side, so we'll come here. So we'll print the value of this node. Then we'll explore the left side, which is null, and then we'll explore the right side, which is null. So here our sequence will end. So if you see, okay, the both of the trees are different. So okay, so just let me erase this. So if you see, the both of the trees are different. So here 7 is the children of 4, but here 7 is the children of 3. So our post-order traversal sequence will be this, right? So now if you compare both of these, so if you see closely this sequence, if we reverse this sequence, let's reverse this sequence. Now what we have got? We have got the post-order traversal, right? So if we explore our tree in this manner, like first the value of the node, then right, and then left, and store our sequence, and then print our sequence in the reverse order, so we'll get the post order traversal, right? So if you have watched my previous videos, this traversal is similar to pre-order traversal. Only in the pre-order traversal, what we were doing, we were first exploring the left and then exploring the right, but here we are first exploring the right and then exploring the left. This is the only difference, right? So in the pre-order traversal, what we were using one stack, right? We were using one stack to print the sequence, right? But what we have to do in this case, we have to print the sequence in the reverse order, right? So to achieve this, what we have to do, we have to use one more stack, right? And then when we'll print the value of the stack, we will get it in reverse order, right? So to solve the problem of the post order traversal iteratively, we will have to use two stacks, right? So in the previous pre-order and the in-order, we were using only one stack, but just because we have to print it in the reverse direction, our output. That's why we have to use one more stack. So I hope now this is clear to you guys why post-order traversal will use two stacks, and uh, how we came to this conclusion that we have to use this sequence, and then we have to print the output of this sequence in the reverse order, so we'll get the post-order traversal. Okay, so okay, so now let me erase this all. Okay, let me erase this as well. Okay, so I will write it here so that I get more space. First right and then left. Okay, and then let's choose two stacks here. Cool. So this is our stack 1 and this is our stack 2. Okay, so let's apply this order on this thing, on this tree. So first we'll start from here, right? So what we'll do, uh, uh, first, what we used to do in the pre-order traversal, first we used to print the value of the node. So what we'll do, we'll put this value into this stack, and then we used to push we used to push that element into our stack, right? Now what we have to do, we have to go on the right, so we'll come here, right? Then again we'll push this element here into the stack, right? And we'll push this element also into the stack. So this is similar to our pre-order traversal. The only difference is in pre-order traversal we were printing the value of the element into the output. Rather than printing it, we are putting it into the second stack, right? So after this we'll again explore the right. So we'll come to the 6. So we will, rather than printing it, we'll push into the second stack, and then we will put it into the first stack as well. After this we reach to the end. So what we'll do, we'll pop the element from the stack, from the first stack, and we'll see if anything is on the left side of it. So there is nothing on the left side, it's null. So what we'll do, we'll pop the second element. Then again we'll check if there is anything on the left side. There is nothing on the left side. So what we'll do, we'll pop the another element from the stack. Now we'll check again if there is anything on the left side. Yes, there is 2 on the left side, so we'll put 2 into the stack here, and then we'll put 2 into the stack here as well. Now again for the 2 we will explore the right side. So we'll reach at 4, so we'll put 4 into this stack, 4 into this stack. Then there is nothing on the right side of this, so we'll pop the element from this stack and check if there is anything on the left. So there is nothing on the left, so we will not do anything. We'll pop the next element. So we got 2 from the stack. We'll check if there is anything on the left side of it. So there is 3 on the left side of it, so we'll put it into this stack, and then we'll put it into this stack. Then we'll check if there is anything on the right side of it. There is nothing on the right side of it, right side of the 3. Then what we'll do, we'll pop the element from the stack, and then we'll check if there is anything on the left side of it. So there is 7 on the left side of it, so we'll put it into the stack, and we'll put this into this stack. Then we'll check if there is anything on the right side of it. There is nothing on the right side of it, so we'll remove the element from the stack and check if there is anything on the left side of it. There is nothing on the left side of it. At this point our stack 1 is empty, right? So what we'll do, we'll print whatever values are there in the stack 2. So we'll keep on printing the elements by popping the elements from the stack 1. So what will be the output? The output will be 7, 3, 4, 2, 6, 5, 1, which is similar to our post order traversal. So I hope now you guys understood how the post order traversal uh, in iterative manner be implemented by using two stacks. So now let's go ahead and write the code for it. Okay, so let's go into our IDE. Okay, so this is where we left our IDE in the last lecture, where we wrote the pre-order traversal in iterative manner, right? Okay, so let's go ahead and start writing the code for the post-order traversal. Okay, so first again, we will check if our root is null. If root is null, we'll just return, because we have nothing to explore here. Else, so what we need here, we need two different stacks, stack 1 and stack 2. The stack 2 will contain the output, and the stack 1 will be used as we used in the previous pre-order traversal or the in-order traversal, the stack for storing the intermediate nodes. So let's go ahead and allocate two stacks here. Stack 1, the stack will contain the intermediate nodes, and then there will be one stack 2. The stack will contain the output. Okay, now let's declare one node which will always contain our current node. And first we'll check our node is not equal to null, or the stack 1 in which we are storing our intermediate node is not empty. So in both of these cases, what we'll do, we will explore the nodes. So let's go back here again. So what we were doing here, what we have to do, first we have to go on the node. So suppose we are starting from the root. First we have to take this node, put it into our stack 2. Then the same node we have to store into the stack 1. And then what we have to do, we have to explore the right side of that node. Okay, now this is completely similar to the pre-order traversal. So in pre-order traversal, what we were doing, we were printing the node. So instead of printing this node, we are putting it into the stack 2, because we have to at the end print it into the reverse order. And then here we are pushing it into a stack. So we'll the same thing we'll do, we'll push the node into the stack 1. Then here, rather than exploring to the left, we will explore to the right. Okay, so let's write the same code here. So when the node is not null, okay, so rather than printing that node, we have to push it into the stack 2. So let's put it into the stack 2. Okay, now same thing, push the node into the stack 1. Okay, so we push it into the stack 1 now. Rather than exploring to the left, explore to the right. Okay, so that's all. Then here what we were doing, again same thing, we will pop the node from the stack. When our node right will be null, what we'll do, we'll pop the node from the stack 1, right, and then we'll explore the left side of it. Cool. So after this while loop will end, that means we have explored the whole tree. So what we have to do, we have to print the stack 2, right? So let's print the stack 2. Let's keep on popping the element from the stack 2 until the stack is empty, right? So let's pop the element. Let's say it element stack to pop, and then just print it. So let's go ahead and print. Let's print this element. Dot data comma and space. Cool. So that's all I have to do. Now let's go ahead and run this program. So let's comment this out, our Prerequisite traversal. Now call our traversal util, make a call to the Postorder Traversal Iterative and pass the same tree here. Let's see what will happen. Cool, so this is our output. Let's go back to our let's compare the output. So 7342651, 7342651. That means our post-order traversal works. Okay, so I hope now you guys understood how to write the post-order traversal iteratively. This is not the optimized code. In the next video we will discuss the more optimized manner to write the post-order traversal iteratively, which will be done by using only single stack. But this is the this is the very important question, like the most important question I would say. Like in the traversal, it's being asked in Microsoft Amazon interview again and again, because it is little bit confusing, and there are a lot of different intermediate question that can be asked by the interviewer, like why are you using two stacks. So you have to justify each and every thing. And so if you see the videos on the internet, or if you go on the Geek for Geeks, they will say I'm using two stacks, but they will never tell you the justification why we are doing it, right? So these are the weapons for the interviewer, so to dig into your thought process, right? So I hope now you will be able to answer all these questions. So now there is only one part pending. So now let's go ahead and check in our code. So okay, so these are the files which are being modified. Let's add them, commit, traversal iterative. So push it to our remote branch. Okay, so guys, if you haven't subscribed to my video, please go ahead and subscribe. If you haven't subscribed to my channel, please go ahead and subscribe my channel. Please like the video if you think it's helpful to you. If you have any confusion, please put it into the comment box. I will reply to your queries. uh, Thank you for watching the video. Thank you.